Is audio video ready for me to get going? All right, sounds good. It's a couple minutes after 2, so I should probably get started so I don't keep you here until 5 o'clock in the afternoon. My name is Nicolle Neulist, otherwise known as rogueclown, hey blue, just about anything, and I'm here to talk a little bit about algorithmic music composition. Before I get started, I'll say a few words about who I am, what my background is, kind of how I got into this stuff. My 2 major hobbies are computers and singing. They're both things I've been doing since I was a little kid. I've got a bit of music training, a few years of music theory class, some piano class, although, I quit when I was 9, so I was a stupid kid. Some vocal training, I still sing in choir. But I'm pretty incompetent when it comes to playing musical instruments. Like, I can play a scale, I can play a few chords on a piano, but that's really about it. I tried to be a guitarist when I was in high school, all the rock bands I listen to want to get into that. I couldn't fret the guitar to save my life. But what I can do is sit over a computer and code. And so when I figured out, hey, I can use code to make music, I thought that was pretty shiny. And last year I gave a music-related talk. It was a survey of open source music software, and I did a brief blip about algorithmic composition frameworks, but it made me really sad that I couldn't talk more about that. So I decided I would talk more about that a year later. Now, a few words about what I'm getting at for this talk, just so you know what to expect. It will be an introduction to the basic concepts and common frameworks of algorithmic music composition. What is it? What software can I use to do this? What platforms can I run on? Programming experience is good. There's going to be some snippets of code, but it's not necessary. If you've never programmed a computer before in your life and you want to start doing algorithmic composition, it's really not that hard to get into. There's only a few kind of libraries, general ideas that you're going to need to know to get started. And then, of course, as you do it more, you're going to learn more. It's a tour of the basic building blocks of music theory. I don't expect any of you to know how to read music. Like, seriously, if you can add, subtract, multiply, divide, if you can, count to 4 or 6 or 8 or however many, beats in any particular group, you can do this. Seriously, you don't have to be able to read music or know all of the common Western and non-Western musical forms or anything that your elementary school music teacher may have said to scare you. What this also is it's an exhibit of music theory and algorithmic composition in context with each other. I'm going to talk a little bit about algorithmic composition, talk a little bit about music theory, and then show some examples of code that makes music. Because, context is everything in this. This isn't a detailed course on any given algorithmic composition framework. I'm not going to teach you all of the ins and outs of the Python MIDI library or common music or anything like that. I'm going to try to keep it as platform independent as possible because no matter what framework or language you decide you're most comfortable in, the ideas are the same. It's also not a detailed course on music theory. I could probably talk for days about music theory, but that's not what this is. I'm going to get into the basics. I'm going to get into what you need to know to start looking at musical forms and saying, hey, here's how I can turn this into code. But it's not going to be a detailed exposition on, chord theory and cadences and everything else. This is also not the only way to do algorithmic composition. That's the important thing. These are some ideas. These are what I thought were helpful in trying to get started with algorithmic composition, but it's not the only way to do it. If there's something I play and you think, oh, this sounds terrible, or the composition choice that I make and you're like, what are you doing? You're smoking crack. That's fine. You can turn around, go home, or go to the games area right now, log onto your computer, and make your own that probably sounds way better than anything I'm going to make. Now, these are kind of the general topics that I'm going to hit on in this talk. I'm going to say what algorithmic composition is, give you a list of free and open source tools and frameworks. Don't worry about writing any of these links or lists down. These slides, as well as any code I show, are all going to be available, downloadable on my website. They're already up there. Then I'm going to go into some music theory basics. Then I'm going to go into the examples. I'm going to discuss one example of making code out of a musical form, and then I'm going to have an example of the other way, starting with some numerical data that doesn't have anything to do with music, and turning it into music. First, what is algorithmic composition? Some of you probably know, some of you probably don't. This is probably the best definition I've been able to find so far. Algorithmic composition is the application of a rigid, well-defined algorithm to the process of composing music. Now, why do people do it? Why would you want to apply an algorithm, a method, something more mathematical, logical, to music? Well, first of all, it's kind of useful for generating themes and variations. If you're trying to compose a piece of music and your inspiration isn't quite hitting you that day, or you keep thinking of the same thing over and over again, and you want to mess with it a little, or mess with it a lot, or come up with something really random, the computer isn't going to get any kind of mental block or composer's block. The computer's going to come up with a lot of different ideas, different variations, a lot faster than you're going to by hand or by brain. Also, it helps you orally interpret the patterns of things. If you see a data set, a picture, an equation, and you think, hey, maybe I can translate these patterns into sounds. I'm kind of curious to see what this would sound like. It's not going to give you everything. There's still a huge amount of compositional choice in that. But algorithmic composition is going to help you get from point A, the non-musical idea that you want to express musically, to point B, having a finalized composition that you can play for your friends and say, hey, look what I made. Algorithmic composition frameworks and tools. Why is this important? I mean, you can start from scratch. Any code that generates data that you somehow then code to be interpreted as sound to come out of a computer can work in theory. Hey, this little bit of binary data represents a G, and hey, this little bit of binary data represents an F sharp in this other octave. But it's not going to be very portable. You're going to have to spend all of this time not only writing your front end, but also all of the libraries that are going to tell a synthesizer or a score editor or anything else how that's going to be played. Because otherwise, you're going to be the only one who's able to play it, or you're going to have to give out the binary, give out everything. And that kind of sucks. I really didn't want to write all of that. So instead, I used MIDI. And I know when I first started looking at synthesizers using MIDI, I thought, oh, the cranky little keyboards that I played around with in the 80s when I was 5 years old. But MIDI is just a protocol to define characteristics of various notes. It's an organized way of expressing pitch, tone length, tempo, that sort of thing. And since it's understood by a wide range of hardware and software, it lets you abstract out all the details of writing those libraries to understand your musical data and lets you focus on just making music. I can plug a keyboard into my computer, download software synthesizers, score editors, a wide range of things that all understand MIDI. So if the code that I write outputs data in MIDI form, I can mess around, okay, how does it sound with this synthesizer? How does it sound with that synthesizer? Pop it up on a score editor so I can see what it looks like on a music staff if I want to take it off and hand it to my friend to play on the piano. That sort of thing. It's just so portable. Now, as far as what language to use, seriously, anything you want. Mess around, if you already know Python or Ruby or Java or Perl, there are already MIDI libraries for those languages, and even more of them. If you'd rather start in an environment that's focused specifically on music, that works too. Either way, you're going to be able to experiment a little bit with, and it's not going to cost you any money. There are so many environments that are free and open source. There's no, okay, this is going to cost me $1 million to get in this hobby. No. So just play around with it. Find one that you like. As far as dedicated algorithmic composition algorithmic composition environments, sorry, can't talk today, probably need another bottle of balls or something. There's Common Music, which is programmable either in Scheme or in SAL, which is a simplified language that was designed specifically for common music, specifically for trying to learn, like if you're just starting out doing programming and want to make music. There's also Athena CL, which is Python-based, but has its own system of musical objects, kind of its own sub-syntax, if you will. C-Sound and C-Sound AC. C-Sound is a pretty popular open source music framework, and C-Sound AC is kind of a Python front end. It's called C-Sound because all the guts of the code are written in C. Open Music is a visual environment based on Lisp. I won't really be getting into visual music programming, but Pure Data is another one, and Open Music is sort of similar in the way it works with the visual patches and connections as Pure Data. Also, you can use a library for general purpose languages. Python, I mentioned MIDI util specifically because that is the library that my snippets of code are going to use. There's a huge long list of MIDI libraries, algorithmic composition libraries for Python. So, if you don't like MIDI util, if you look at my code, it's like, what in the world? Play around with other libraries. Java has a couple of libraries, JMusic, JFugue. Ruby has a bunch. JSound MIDI, MIDI Lib. Perl, MIDI is the main one and the one that I saw most often in Perl, but there are a few others, and if you're a Perl monk, you can search around CPAN to try and find what you like. CPAN being the Comprehensive Perl Archive Network. Played around a little bit with that, but I'm more of a Python girl than a Perl girl, so. And again, other languages, seriously, Google is your friend. You will probably find one. And if you don't, then it's really not all that hard to write your own. The MIDI specification is huge. I have never endeavored to print it all out because it would probably waste way too much paper. But, depending on the scope of the project, you may only need a few parameters of the MIDI standard. A lot of these libraries that I mentioned don't necessarily implement the entirety of the standard, but they're compatible with anything that does implement the whole standard or the main parts thereof. So learning the entire MIDI standard is not necessary. I will tell you, I am nowhere near knowing the entire MIDI standard. Not at all. Like I said, the code in this presentation is going to be in Python and use the MIDI util library for representing the data in MIDI format and being able to save it that way. But I'm going to try and keep my discussion of the principles as language agnostic as possible, so you can go ahead and leave this talk and apply it to whatever language that you choose. And if anything that I talk about or any of my descriptions of the code get too tied to Python, feel free to raise your hand. I mean, if you're confused about anything I say, please raise your hand and have me explain it. I don't want to go over people's heads. Now to the meat. Short introduction to music theory. Why in the world do you want to know some music theory? I mean, it gives you a context of what you hear, what you create. And, I know a lot of people that are like, I don't want to learn music theory. I'm making something that's more modern, more avant-garde. I don't need music theory. I'm of the opinion that knowing what the forms are and how it's put together, it not only gives you a context for creating, but you can say, hey, I don't like this. And you can more thoughtfully throw forms by the wayside, throw traditions by the wayside. Learning it doesn't bind you to say, okay, I need to make things that are in a key. Okay, I need to follow what this person says is music, or that tradition says is music. And yeah, just knowing what's there, being able to just listen to a piece and be like, okay, I recognize this. This is sounding kind of major, sounding kind of minor. Yikes, that's atonal. It's just good to know. I like the background of it. Rhythm is one of the main building blocks of music theory. Beats, like 1, 2, 3, 4. 1 and 2 and 3 and 4 and, half beats, whole beats. Because when I go later in the code, I'm not going to tell MIDI, this piece is in 2 or 3 or 4. I'm just going to say, this note is 1 beat. This note is half a beat. This note is 2 beats. And that's really all you need to know to get started. However, getting a better idea of what meters are can make it a little more sophisticated. Like a measure, if you're looking at a piece of music, the things just between the bar lines, those are just groups of beats. simple measures, like, simple kinds of meter, like 1, 2, 1, 2, 1, 2, 1, 2, 3, 1, 2, 3. 2, 3, and 4 are really the main simple kinds of meter. Compound symmetric kinds of meter are groups of, usually groups of 2s within 3s or 3s within 2s, like 6/8 time or 9/8 time. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Things like that. Then you can also get into weird, like cracked out complex meters. There's kind of reasonably simple, like, in 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I see that not too rarely in more modern music that's been composed, things in 5, things in 7. And then sometimes, you'll see these really weird times. It's like half note plus quarter note plus eighth note plus this, and it's like, what in the world are you doing? I've never seen music written out like that before. So you can be as simple or as complex as you want, but having rhythm is one way you can organize your music. Alternately, you can decide not to have a rhythm whatsoever. And I've written some music code that deliberately flouts rhythm by allowing note lengths in any gradation between half a beat and 6 beats, but the idea of beat is it's completely arbitrary. So again, rhythm is one of those things you can know or you can flout. Pitch and key. Even if you have to, think back to music class, everyone's probably heard this before. That's a major scale. That was in C, but I can move it to a different part of the piano, and the distances between notes are the same. And what's kind of nice is once you know the distances between the notes in a major scale, 2 keys, 1 key, 2, 2, 2, 1, you can start on any key that you want. And that's, when I get to more how to express stuff in MIDI code, knowing that's going to be important because the numbers for notes in MIDI are very closely tied to the keys on a piano. Again, with chords, you have a note that's based on, let's go back to the C scale. The first, third, and fifth, it's always going to have that bright major sound. Like the second scale in F, it still kind of sounds the same. Minor chord has a little more lower sound to it, a little sadder, a little not so bright. And if I move it to another key, again, the second, fourth, and sixth, they're going to have the same thing. And knowing that that pattern can be moved anywhere on the keyboard, again, is going to help you abstract out these ideas of chords and keys when you're doing your algorithmic composition. Again, if you want to take this further and learn something about common chord sequences, you have chord sequences that really, really pull back to, give a feeling of final. You heard it kind of wanted to go back, or if I've been playing stuff in that key, and then I go. These keys are. That doesn't sound, it wants to go back there. And again, I'm not going to go into too much more detail than that, but if you're kind of used to hearing one key, traditionally you're going to want to know where those chords go if you want to follow that pattern. Or if you really want to leave your listeners with a sense of hanging, maybe you do want to end on, that 5 chord. Like the one that felt like it was really hanging. Find the keys again if I can read this. No. I can't read today. There we go. Wants to go there. And that 5 chord is always going to sound like it wants to pull back to the 1 chord. So that's just, one of the rather basic techniques of leaving your listener hanging. Again, if I go too far into this, it's going to drag on, but knowing this and knowing that there are patterns that can be moved around the keyboard will help you abstract that out. And this is where it falls together. MIDI assigns numbers to each of the keys. Like middle C, this note here kind of in the middle of the keyboard, that's number 60. And then 61, 62, 63, 64. So 60, 62, 64, 65, 67, 69, 71, 72. That's the that I played. And plus 2, plus 2, plus 1, plus 2, plus 2, plus 2, plus 1. You add or subtract that, you can move that anywhere around the keyboard. So basically, even if you can't read music, even if you listen to a note and you don't know that it's necessarily C from a hole in the ground, building chords and scales becomes addition and subtraction, which is nice. Knowing that, you can start turning musical forms into code. Before I do that, I need to step out of this just a second and kill one of my music engines, because what was making that keyboard work is going to make all of the music that my slide program tries to play not actually play, which would be a shame, because this is getting to the point where it's stuff that I can write code to play, but if you try to sit me in front of a piano to play it, it's not going to sound right. You're not going to want to listen to me play it. Again, this is where you can make choices to follow the form or not. Code in things that you want to follow. Don't code in things that you don't want to follow. And when I'm showing you code snippets or playing you any examples, ask yourself, okay, I've described this kind of musical form. What did I do that was required by that? What did I do that wasn't necessarily required by that, but I decided to put it in anyway, maybe because I thought it sounded good, or because, it would make it a decent example, or whatever? What would you do differently? As far as my example of turning a musical form into code, I'm going to use 12-tone music as my example. Now, what's 12-tone music? It's a modern style. It was introduced into, the mainstream of musical knowledge, if you will, in the 1920s by a composer named Arthur Schoenberg. And it's not really going to have an idea of a key. It's structured atonality. It uses iterations of the 12 tones within an octave. Each tone must be used once before any tone repeats. So it's based on a tone row. You see there I've got the keyboard diagram of C up to C. Using the white keys and the black keys. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then it repeats again. So you need to use all 12 of those in some order before you use it again. How do you make a tone row in Python? That's actually pretty simple. A tone row is just some ordering of 12 integers in a row. That's really all it is in a piece of code. So I start with a list. That base tone row is just an empty Python list. And then I make a list of just 12 in a row. And in that piece of code, that start tone is a parameter applied by the user. And then it starts with that plus 1, that plus 2, all the way up to that plus 11. And then it shuffles it into some kind of random order with the random.shuffle method. And that's really all it is. That's all you need to create a tone row. It's going to come back with some arbitrary list, some arbitrary ordering of the notes between what's specified by the user and 11 half steps above that, 11 MIDI tones above that. Then, under the conventions of 12-tone music, there are 4 allowable basic orders of the tone row. There's the prime, which is just that tone row that has been defined by the original tone row generator, if you will. Then there's the retrograde, which is just backwards. So the retrograde method there, it's a little small. I'm sorry, it's a little hard to read. It says retrograde tone row. That's just tone row dot reverse. It reverses the item in that list that was generated. Inversion is the one that's kind of funny and was not necessarily difficult, but definitely, the most sophisticated to create an algorithm for. Because the inversion, you start from the first note of the tone row and you reverse each interval. So let's say the first two notes of your original tone row are 65 and 67. The first two notes of the inversion are going to be 65 and 63. In the original, you go up 2. In the inversion, you go down 2. You just reverse each interval between the notes. And so you might end up getting notes in your tone row in different octaves because you're going down when you're going up, or you're going up when you're going down originally, but you're still going to get the same 12 tones, but with the intervals inverted. And then yes? That's next. Yes, no, there will be that. I'm going to talk about what it is, and then there is going to be an audio snippet where it plays a tone row, a retrograde, an inversion, and a retrograde inversion with breaks between them so you can kind of clear your head. The retrograde inversion, since I've discussed the retrograde and the inversion, it's just the inversion flipped. I'm pretty sure the next slide is the sound example. Okay. Did you freeze? Ah, come on. So that's the code that I showed you played. It played the prime, then the retrograde, then the inversion, then the retrograde inversion. If you want to play around with this code or see these methods, change them around, I will have a link at the end where you'll be able to download all of this code and be able to generate this stuff on your own with just Python and the MIDI util library added. That library is up on Google Code, freely available, open source. So you can do this at home as well. Now those are the basics of 12-tone music, but it would be kind of boring to just sit there and listen to, okay, this is the prime, this is the retrograde. You want to add maybe other voices or other ideas to it. You can randomize which iteration plays. It doesn't always just have to be the prime, then the retrograde, then the inversion, then the retrograde inversion. So I have here, you've got your basic tone row, and then it picks a random number between 1 and 4. And if it picks 1, it plays the tone row, the prime. If it picks 2, it does the retrograde. 3, the inversion. 4, the retrograde inversion. That's not the only way you can do it. I just decided to do it randomly because I thought it would make a good example. You can, you could say, hey, if it played this last, then play something else next. Kind of go for more of a Markov chain approach with it, where what did last weighs the decision on what goes next. But I decided to keep things simple because this is code for demonstration purposes. And then here, I'm sorry, I don't think I've explained this. This here is the actual implementation of adding notes in the MIDI util library. There's the tone. For tone and tone row, you've decided whether it's going to be the prime, the retrograde, the inversion, or the retrograde inversion. That's going to give you the list of the next 12 notes in your piece. It adds note, the track, first track, second track, third track, because you can do polyphony where you layer the tracks over each other. Channel, that's generally a definition of what instrument. there's no standard of channel 1 is always this, channel 2 is always this. It depends on how you've set your synthesizer up, but you can do different instruments in different tracks. Pitch is what note it is. Is it a C, is it a C sharp, etc. Time is how many beats. So, let's say earlier in the code I defined the tempo as 120 beats per minute. One for time. One for duration would be 1 beat. Time is where in the piece it is, like how many beats in. So, the first it would be, time 1, duration 1. If you want the 15 beats in to spend 2 beats, time would be 15 and duration would be 2. Volume, again, that's a MIDI specification, how loud you want your note. Do you want to code it so that all your notes are the same volume? Do you want to put some crescendos and decrescendos in there to kind of give it a little more musical interest? You can define that in your add note statements. And then here the time plus 1, like I said, since that's an absolute notation of where it is from the beginning of the piece, you want to implement that. This here, it just says time plus 1 because this is all single beat notes. What if you don't want all single beat notes? You can vary the note lengths. I did not realize how poorly this red was going to show on the projector. The note lengths here I have varied all the way from 6 beats down to 1/4 of a beat. If you're keeping track from home with traditional music theory traditional musical notation, anything from a 16th note to a dotted whole note. I've got many gradations in between. 4 beat notes, 2 beat notes, 3 beat notes, 1 beat note, half beat note. You can use as many or as few of them as you want for your composition. And you can put it in there and say, okay, I want to use only these kinds of notes, or I want to randomize which note is going to be used. You can also vary the octave of the notes. Like I said before, it's going to be from N to N plus 11 in that tone row. But under the conventions of 12-tone music, you can change the octave of the note if you want. You just need to get all of those scale degrees in before you start the rotation of scale degrees again. Since N plus 12 is going to be the same scale degree, like an E or a C or whatever, as your N, you can take it N plus 12, or N minus 12 is an octave lower. So that kind of gives it a little more, okay, it's not the same range of the voice or the same range of the piano anymore. It'll give you a higher feeling or a lower feeling. That's based on the code snippets that I was just showing. 4 iterations through the tone row. Starts at a 65, which is the F sharp above middle C for those keeping score at home, but still something, even if you're not kind of very mid-range type note. All tone lengths, everything from 1/4 of a beat to 6 beats are allowed. I think I set the tempo at 150 beats per minute just so it wouldn't drag on. I think I tried 120 for my first draft of that example and was like, this is probably going to take over a minute and I only have an hour up here. Again, if you download my code off my website, you can change all these parameters when you run it and play around with it that way. Only allow a certain group of notes or have no meter at all, like a completely random distribution, not based on just single beats and half beats and 2 beats, like increments of your tempo. That's always kind of an interesting effect because it has no key and no tempo. That's kind of fun. Now, an even more complex example, which I'm not going to completely go into because I only have a limited amount of time, is a streaming radio station that I set up maybe 2 months ago. It uses algorithmically composed 12-tone music based on the code from this talk. Like several of the functions that I showed you today are in the code for this radio station, and the major parameter it adds is polyphony. One of the random choices that it gives is it's going to have 1, 2, 3, 4, or 5 voices at the same time. And then there's code in there to make sure that the tone row has been gone, the tone row or the retrograde or the inversion, etc., has been gone through in each voice before it starts again in each voice, which was a little weird to work out, but, you know, I eventually got the algorithm to work. And, you know, it's called lovely spam because that's exactly what it is. Nightshade told me earlier this year about spamradio.com, and I got really annoyed that it played the same, 10 spams over electronic music over and over and over again. I'm like, this is great background music, but I know all the words to these spams, and this is really annoying me. So I decided to write some code to make algorithmically composed 12-tone piano music, text-to-speech spams over it, and I'm constantly adding new stuff that lands into my email box. So it's kind of weird, but it's fun. It's good background music, and it's an example of what can be done with algorithmic composition and specifically 12-tone. Again, this is only the beginning. This is one example of a few things that I did with one style of music. Where can you take this out from here? If there's a musical form that interests you, or a song, or just an idea that interests you, look into the mathematical underpinnings of the form. What are the patterns in pitch? What are the patterns in rhythm? Key, does it have a key? Does it not have a key? What sorts of harmonic patterns do you see? And then create functions to manipulate those. Okay, I see a lot of major chords, major harmonies, and I know that a major chord is going to be a note plus 4, and a note plus 7 for the basic triad. Look, reduce those things into their mathematical forms, and then create functions. And then do a lot of listening. I mean, it's just like cooking, like never trust a cook that doesn't, kind of taste as they're going through to make sure that their food tastes good. Test your functions. Listen to them. Ask yourself, is this what you want it to sound like? If not, mess around with it a little bit. Change your algorithm until it sounds the way that you want it to. I mean, there is a huge creative element to algorithmic composition, despite what its detractors may say. And if you look around at it, there are plenty of detractors that are like, turning music into math takes all the creativity out of it. I argue it doesn't, just because there's so many choices you have to make when you're writing those algorithms. Now we've started with a music form and turned it into some code. Now let's start with something that has nothing to do with music whatsoever and turn that into something musical. This is another place in which it highlights the creativity of it, because if you're starting with something that has no intrinsic musical characteristic, you're making conscious compositional choices to how to map parts of that data set to things that are musical. Again, there is no one way to do this. A lot of the choices that I made in this section are to make it, a decent example, sort of this is how to do it, so it doesn't get too insane or lost in the context of an hour-long talk. But there's a lot more you can do with this once you know the ideas to it. First of all, choose a data set. I chose a data set that was very small since it was explanatory. Specifically, I was just looking around for reasonably small data sets. I found a website. I have the link in the comments of my code. I think it was somewhere off of CMU's website where they did have data sets for learning statistics, and they were just small data sets to try and get the hang of statistical analysis. It was a list of some quarterbacks, and the top few quarterbacks, maybe 25 or 26, based on rating, and talked about how many touchdowns they threw for and how many yards they threw for, and I'm not really a big football fan, but it was a good-sized data set for the sake of example. And once you know the ideas, you can choose a larger data set with more parameters to change more factors. I took it down to just, the quarterback ratings and the yards because I wanted to do the duration of the note and the pitch of the note. The way I normalized the data to kind of put it into a range that would make sense for MIDI, I used the quarterback ratings for pitches, rounded them to integers, and then shifted them down by 16, because even though the original range of ratings, which was 79 to 97, those are all totally valid MIDI codes, the notes would be way up here, and that would get really boring and really squeaky. So I brought it down a little bit. No, never. I don't squeak. I never squeak. And then, anyway, then I took the note lengths. I used the passing yards, but since they were all in the range of about 10,000 to 50,000, and that would make no sense in the context of beat per minute, I just divided by 10,000 and rounded. So instead of being in a range of, 10,000 to 50,000 or whatever, it would be, between a beat and 5 beats, which, normalizing to 120 beats a minute or 150 beats a minute, that just made a lot more sense and made the numbers a lot easier to conceptualize and deal with when moving into music. Again, those were choices I made. That's not the only way it could be done. For example, you could have decided to use the quarterback ratings for note lengths and the passing yards for pitches. Totally arbitrary. As you can see, that was mostly a descending melody, except for that kind of outlier at the end, because that's how the data was laid out. And I decided at first, okay, I'll just play this in the order that the data was laid out. And then, it went descending because it was laid out in order of quarterback rating. And then they tacked on at the bottom this guy who was apparently really good, but didn't play for a league that the NFL recognized. So it's like, hey, and there's this guy too, and we shouldn't leave him out, but he had a really high rating, but didn't play in the NFL. So I did it in the order it's printed at first, and then that's obviously not the only thing you can do with it or the only thing I did with it. You can start playing around with it some more. That was the same pitches. I'm sorry. I think my OpenOffice presentation software decided to smoke crack. I need to fix the slide and re-upload it. I'm really sorry about that. Those were the same notes as in the first melody. Each note corresponds to the same rating and yardage pair, but I randomized it. And so, there were some notes that some sequences of notes that seemed very melodic, kind of consonant. There were some that, were very clearly not, kind of more jarring intervals. I think I heard a tritone in there. But that said, that's only one way to do it. You could take the notes sitting in front of you, be like, okay, I want to make something that sounds very, traditionally consonant, or try to use these notes to follow some kind of, musical form pattern. Okay, I want to do something more traditional, suggesting the, 1, 4, 5, 1 chords or anything like that. Again, this is why having at least a working knowledge of music theory is nice, because you can look at those things and be like, hey, what if I try to shove them into this box? Hey, trying to shove them into this box is really, really bad. I should really do something else with this. And again, this was a very small data set. It only had 26 data points, and actually the original data set did have other aspects to it. I could have used a couple of the other parts of the data set, the number of touchdowns or touchdown passes or anything like that, to define harmonies or volumes or change the instruments, or get kind of the attack or decay. Really anything that's defined in the MIDI protocol is something that you could have assigned other columns of the data to make it even more sophisticated and more interesting. You could also use a data set with more points. You know, if this thing had 50 pieces of data, 100 pieces of data, 1,000 pieces of data, it would result in a longer piece of music, or just more notes that you could mess around and place in a different order. Now, in conclusion, this is just a beginning. I mean, there were a few ideas that kept coming up in this, and I think if you get one thing out of this, it's the idea of compositional choice. Even though it's algorithmic, even though you're reducing these musical forms into math or starting with these statistical or mathematical ideas, how you represent them in music, how they end up sounding, is up to you. I mean, it's a great tool, but it's just that, a tool. There's always going to be room for your own ideas, or tweaking it, changing it, figuring out how you want it to sound. As I said, the slides are available on my website, rogueclown.net/presentations. I have the slides in PDF form, and I'll fix that and put them up in open document form as well. I have a zip file of the full code. I mean, all the code that I showed was functions, but the code examples that are in the zip file are full-on programs that you can read through, edit, play around with, use to generate MIDI files, and what they output. You can play them in, Timidity or whatever MIDI synthesizer or MIDI program that you feel like using on your computer. If you have questions, I think we probably have a little time right now. You can always bug me on email, rogueclown@rogueclown.net. Bug me on Twitter, I'm @rogueclown, or just, harass me at some point during the con. Thank you. Does anybody have any questions? Yes. The function that I showed, where is it? This function here adds the notes to the track, and then at the end of the code, there's seriously just a, I don't even remember the name of the function, like MIDI file output or MIDI file.write. There's just a method that you call at the end to write all of these add notes that it's been saving in the MIDI file object out to a file. And then that saves the music. So if it's if it's something randomized, which a lot of this code is, then it goes through, randomizes for that one time, writes it to the file, and once you've written the Python script, you have a MIDI file. Then you can play it through whatever MIDI synthesizer you have running on your computer. I haven't used Winamp in years. I'm not sure if it actually plays straight up MIDI files. I'm a Linux user, so what I generally do is I can use Timidity, which is it's a MIDI player, MIDI synthesizer for Linux. I believe they have it for other platforms too, but it's what I use on my Linux box. And I know it's Timidity-O-W, the name of my MIDI file, and then I can use -o and name my output file, whatever. That outputs it as a WAV file. And a WAV file will play pretty much anywhere. Or I can use lame to encode it into MP3 or change around the format, do whatever I want with it. But once it's written out at the end of the script in the MIDI file, it's ready to be converted, played through a MIDI synthesizer, overlaid through other things in a MIDI sequencer, whatever you wish. Thank you. Any questions? Other questions? Yes? Seriously, I don't have any. I don't have any method to my madness as far as data sets. I mean, I don't honestly do a lot more with specific musical forms than I do with data sets. But if I want to play around with a data set, it's more just like I Google around and it's like, hey, what I want to play with, there's this data set that fixes it. So I'm sorry I don't really have a better answer. Like that's not my personal focus within algorithmic composition. I think it's more, I come from, I've had a lot more like classical type training, so I'm kind of fascinated by the music theory forms and trying to turn those into code. So I don't do the data set stuff all that often. Yes?
So slight variation on the question. Do you use those to audiolize, like visualize stuff for your own understanding, or do you use it
Generally more for ideas for writing music or listening to. If I'm trying to understand something that's not presented to me in a musical way, I don't think turning it into music really helps me understand it any better. But I use it to get ideas for, okay, I'm not getting any ideas as far as what where to start on a composition, or sometimes it is the composition, like for my radio stream, or I generally do it more for the end being what music comes out of it, not necessarily to understand something that's not generally musical. Anybody else? I have not considered teaching a class using statistics. Seriously, my statistical background is, the statistics for political science majors class that I took my 4th year. That's not what it was called, but, I was one of about 80 bajillion political science majors in there, and it didn't go too much more deep than this standard deviation, which means I should probably learn more statistics. Anybody else? Thank you all for coming.